Welcome to geometry class. This is the in-class lesson for section 7.2.4 on trapezoids. Nobody makes a greater mistake than he who does nothing because he could do only a little. Edmund Burke said that. Our objective today is I can learn definitions and properties of trapezoids, and our assignment will be CPM section 7.23, numbers 83 through 87. Okay, I want you to pause and try this warm-up. Do it on a piece of paper. You can either do a flow chart, and I gave you some hints as to what to write down, or you can do as a two-column proof, and I put in the information there. Pause this video, try and do it. Okay, hey, welcome back. See how you did on this. In this one, we were trying to use hypotenuse legs, so we have to use right triangles. So remember, the upside down T means perpendicular. So the first thing I can say is OEM, and if you put down 1 and 2 here, at these angles right here, if you wrote down 1 there and 2 there, that would be fine. Okay, instead of OEM and OEP. But those are right angles by definition of perpendicular. And since I was going to use hypotenuse leg, then I can say those are triangles are right triangles by definition. Right triangles I'm given. I have the reflexive property, gives me this right here. OE is equal to itself. And therefore, the triangles are congruent by hypotenuse leg. I don't want you to forget how to do proofs. They will be on the test, and we want to make sure you still continue to know how to do those. You did a real nice job on the geometric reasoning portion. Now they'll be on geometric connections. Okay, questions on your practice to learn. So a number of these, are congruent triangles. So let me just show you. Here, these are congruent triangles by side, side, side. So you use the reflexive property to do that. Here, I don't think, well, these two angles are equal, but these, we don't know the corresponding sides are in the same spots because of that. So I don't think we can prove that those are congruent. Here, if we use the addition postulate, which is something new. If I add this part onto both of them, I can then say that this yellow side and this purple distance here are the same. I have angles then, so I would have, what would that be? Angle side angle. Here this is 90, so so we know, since it forms a straight line, those are 90. So this is an example of hypotenuse leg. Okay. 77 exterior angles. Remember, this angle here is equal to the two remote interior angles. So CAB, if this is 46 and this is 37, since I can calculate this yellow angle and then I subtract it from 180, it turns out that to get that, I subtract 46 and 37 from 180 to get that yellow angle by triangle angle sum. So the exterior angle is equal to the sum of the two remote interior. And then they ask you to do that again. On this problem, since it's isosceles triangle, and I drop down the altitude, it produces two congruent triangles. So what we find out here, let me extend this up a little bit, is these two triangles are congruent by hypotenuse leg. So that means corresponding angles are congruent. So those are 18 and 18. How would I find the BD? I can now, well, I know this is 4 and 4. And so now I could use my trig where this is 18 and this is 4. Now I can find that. So I can use the tangent of 18 is equal to 4 over x. Now I can cross product that and find x. Then I got the height of the triangle. I know the base. And so there I can multiply the height times the base and divide by 2. This one, again, 0, 0. Here's A. B is at 6, 0. There's B. C is at 8, 6. And D is at 2, 6. Let's call that D. So here is your shape. Now you can find the lengths. These are pretty easy to find. These are 6 and 6. Here you have to use the Pythagorean theorem to find those lengths. To find the equation of the line, what you have to do is connect these 2 points. Find the slope between those 2 points. That'll give you your slope. And then plug the points in to find your y-intercepts for that yellow one. And same thing here. What color haven't I used? I do the same thing here with this line. 0, 0 is going to be the b value, and then I can just find the slope of that line, making a triangle. You should have a pretty good mess on your graph, but you should be able to do those. I suspect we're going to have questions in that in class. Okay, well, there's some more problems on here. Let me go over this. So you're making estimates. So what you're going to do is you think about what are the 2 perfect squares between. So this is 4. The next one is 9. 5 is closer to 4. So this is 2. This is 3. So this will probably be 2.2, 2.3, 4, 5. 85, it's going to be greater than the square root of 81. That's 9. And the next one, 10 squared, is 100. It's going to be much, so this is 9, this is 10. 85 is pretty close to 81, so it's going to be 9.1, 9.2. Again, making estimates. I suspect you won't have too many problems on this one, other than on this bottom one, D. This is going to be 2x plus 21 also, because of corresponding angles, because those lines are parallel, and then you have vertical angles, so set those equal. Here you would use this pair, and you could find this angle here by subtracting it from 180, and then you find this pair and use law of sines. Here, since it's isosceles, take 52 minus 180, and then divide it by 2. Add these 2 together to get equal to 180. So that's your homework assignment. Quick synapse. Hopefully that answers most of your questions. Okay, so now what I want you to do is draw a non-special trapezoid. Pause it a second and go ahead and draw this. All right, welcome back. So I'm hoping it looks something like this. What in your mind did you do? What made it be a non-special trapezoid? I'm hoping you said, hey, all I want to make sure is that those 2 sides are parallel. And so this is an example of a quadrilateral with 1 pair of parallel sides. Okay? Now, let's draw on the diagonals. Okay? And there's nothing special that happens with those. Diagonals aren't the same. They're not congruent triangles. Nothing. But the only thing I can say is before I drew those in, since those lines are parallel, then this angle here and this angle here are supplementary, right? And the same thing, this angle here probably is supplementary to that angle there. So that will be the only property we have. If it's a trapezoid, then lower base angle is supplementary to the upper base angle on the same side. So these angles here in yellow, these angles in yellow, if I get this to be yellow, and here are considered base angles. And the same thing, the other top 2 are considered base angles. Okay, so let's write this down in our practice, our reference sheet. So draw in, by definition, we know quadrilateral with one pair of parallel sides, and then the lower, if it's a trap, then the lower base angle is supplementary to upper base angle on the same side. Pause and write that down. Hey, welcome back. Now on a piece of paper, draw an isosceles trapezoid. What happens there? Pause and do that. Hey, welcome back. I'm hoping you drew something like this. I'm hoping, what makes it? So, that makes it a trapezoid. But now what makes it isosceles? Isosceles means two, and it's the non-parallel sides are the same. So the definition of a trapezoid will be with a pair of congruent base angles and non-parallel sides are congruent. So these angles are equal and these two base angles are equal, okay? Now, if I draw in the diagonals, I'm going to draw those in. I want to focus on these triangles here in yellow. This triangle and this triangle. And remember, base angles are equal, so this angle is congruent to this angle. So maybe I should make that second one purple. I think that might help here. The purple triangle and the yellow triangle are congruent by side angle side because this is the overlapping side. So therefore, what do we know about the diagonals? By CPCTC, the diagonals will be congruent. So let's go to our reference sheet and let's write that down. Maybe get that. So isosceles means this angle and this angle. Okay, those angles. Pair of congruent base angles and non-parallel sides congruent. And what do we know? That the diagonals are congruent. So pause and write that down in your reference sheet. We will use this during the test. And let's go back. Well, welcome back. Let's now look at this. Can you draw a right trapezoid? What the heck does that mean? Pause and try and draw that on a piece of paper. Okay. Well, I'm hoping you drew something like this. I'm hoping in your mind you thought, oh, these got to be parallel, but now I have right angles. So the definition goes like this. If it's a trapezoid, it's a trapezoid with two right angles. That makes it a right trapezoid. 3 would give us a square, so it's only 2. So let's take our reference sheet, and there's no proper, well, we can look back at that. We can look at the diagonals real quick. This diagonal and this diagonal give me no congruent triangles, pretty obvious. So I think it's just the definition that we're going to work with. So in your reference sheet, let's draw this out. Trapezoid, let's put the right angles there. And then let's write this down. Trapezoid with 2 right angles. Okay, so on the back side, we're going to fix this. So this has one pair. So what happens with a quadrilateral with one pair of parallel sides? It becomes a trapezoid. 2 congruent non-parallel sides gives you isosceles trapezoid right here and here. And we'll make this here. And the restriction here is 2 right angles. Well, right angles. Okay, here and here. Okay, and this gives us a right trapezoid. Okay, so any properties for a trapezoid are true for a right trapezoid and isosceles, but then they have congruent sides and base angles are equal. Here you have right angles. Okay. Any questions? That's what your whole backside should look like on your reference sheet. Now, your assignment is 724, numbers 83 through 88. And there it is. Go to your CPM electronic book to do those. I want to go to the closure. Okay, for each pair of triangles determine, so pause this and go ahead and try and do this. Hey, welcome back. Since it's a parallelogram, by definition, I know these are congruent. Therefore, if parallel lines and alternate interior angles are congruent, so that makes these congruent. This is equal to itself. So ADC is congruent to CBA by, what would that be? Angle, side, angle, congruency. Now, let's look at this. Pause it and try this. Hey, welcome back. So what we're really focused on is this yellow triangle here. And since the lines are parallel, we know this is a right angle also, corresponding angles. Since this is 5 feet, that makes this yellow part 27. Now I have a right triangle. I know both legs, so I can use the Pythagorean theorem to find x. I can take 27 squared plus 40 squared equals x squared. You can go ahead and do the math there. And I can use trig to find that degree. I can go the tangent of y is equal to 27 over 40, and then use inverse tangent to find that. Okay? Hey, well, it's been fun teaching you. Hopefully this helps you a little bit on getting prepared for the quadrilaterals. Have a good day.